Hey all. I noticed a lot of people are struggling with this question in the milestones, so I thought I would do a supporting video to help. I'm not going to use salary data or temperature data. I'm going to use this monthly listeners data and show how I can do this work. Okay, so I'm going to also change the percentage here just to be slightly different. All right, I'm going to say the 60th percentile. And so I'm going to start with that equals percentile dot exclusive. Doesn't matter if it's inclusive or exclusive. And I want to find the 60th percentile. And so this is the number I'm working with here. 2292. I'm going to put commas in because I'm having a hard time. Okay, so it's 200, well, almost 3 million people. So I'm going to go through this list until I find something that's close to 3 million. Oh, there's one right there. Stacy. Stacy. Okay, so her number or their number, I actually don't know if that is gender. All right, is this. So I'm going to use this as my target number and I'm going to make a sentence. Now I realize you're not math teachers, so you're not used to making sentences, but the construction of the sentence doesn't need to be, or question doesn't need to be complicated. Ben's favorite band is Stacy. I definitely have to look up Stacy, which has about 3 million monthly listeners. What percentage of bands have more than Stacy? More what? Have more monthly listeners than Stacy. Okay, so just to kind of help with the construction of this, first sentence is just a little bit of context. So you're talking about salaries, you're talking about temperatures, you're just setting the stage. Then you get to the question. And typically it's going to be what percentage, what proportion, have more, have less. And then, I decided to go with the name of the artist instead of putting the number directly in, but I could have put the number directly in. I could have said have more than this number of monthly listeners, right? I mean, it's basically the same question. What percentage of bands have more than 3,049,521 monthly listeners? These are two ways of asking pretty much the same question. I could have said have less than, right? It doesn't matter. You're constructing the question. From there, you're solving the question. I'm going to stick with my original concept and we're going to go from there. Okay, so of course, the first thing to do is to calculate the z-score. And I need the mean and the standard deviation. So I'm going to do equals average. You would already have these numbers, but I'm just doing this really quickly because I don't. Using the population standard deviation because this is a population of artists in Spotify. And now I'm going to do my z-score calculation, which is equal to, if I'm using the 3 million number, then I would put in 3 million. But if I'm using this number, I can put this directly in minus the mean divided by the standard deviation. There's my number. I'm going to take it out of accounting and make it this. So negative 0.29. And now I want to say what percentage of bands have more monthly listeners than Stacy. So I'm taking this number and I'm going to either use the norm.s.dist or I'm going to get it off of the z-score table and explain it. Okay, and so then this is a percentage. So 39%. Now careful here because remember that the norm.s.dist and the table give me the left facing amount. And I was sort of thinking about this because this is a negative value. So just sketching this out here, I've got my normal distribution. I drew my line to the left of the center. This is the mean. I'm over here with the z-score of negative 0.3 more or less. So I'm to the left of the mean. I'm going to use the little mu here for the mean. All right, here's my z. All right, so my expectation is that the less than part is going to be less than 50%, which is the 39%. The more than part is the complement of that. We talked about that in class. So the way I would do that is I would do equals 100% minus my 39%. So there's 61%. Okay, so based on my z-score calculation, I would guess that 61% of bands have more monthly listeners than Stacy. So Stacy, now one of the things that's kind of making me pause here is that this is sort of inverted from the way that we started, which is the 60th percentile. The 60th percentile would put my numbers in order and find the 60% mark and say, who is at that mark? So there is going to be a mismatch here between whether this is accurate and not. And this is the second part, which is that you need to evaluate this. So first, let me highlight my answer. 61% of listeners have more monthly listeners. Sorry, 61% of artists, we're talking about artists here, have more monthly listeners than Stacy. Okay, I can't stop. I can't help it any. I gotta do it. Gotta do it. Stacy. Girl group. Come on. Oh, it's a K-pop group. Oh my God. Let's listen to some K-pop. Here we go. Oh. Sorry, I'm making you watch this commercial. For the rest of this video, we will listen to Stacy. Okay, wait. So now we're going to determine whether this is true or not. Okay, I can't do it. I can't do it. Sorry. Very hard to think and listen to Stacy at the same time. All right. 61% of ours have more monthly listens than Stacy. Let's do a countif. Equals countif. I'm going to do this, and I'm going to say, I want to know if these numbers, each number is greater than or equal to this number, 3049521. Okay, 7269 and 7269 equals how much, what percentage of the whole thing? I don't know what the whole thing is. Let's do the count on the whole thing. All right. And so this is the actual percentage. This makes a lot more sense compared to the 60th percentile because the 60th percentile would mean I'm larger than 60% of the population, smaller than 40% of the population. So this makes sense. And so my evaluation is that the z-score approach did not work. I'm not shocked because, drum roll please, if you remember looking at this graph, this is not a normal distribution. This is a very skewed distribution. And so that means that this whole z-score approach doesn't make sense for this particular distribution. It's a very important thing that I'm trying to get at, and I don't know whether you have a normal distribution or not, but I want you to kind of see that if you apply these things, they may or may not work in terms of your actual distributions. We're doing it two ways. The first part of the question was looking at your 68% statement. The second part is this, making a question, applying the z-score process. What is the z-score process? Use information in question to find z-score. Use the z-score to find the probability / proportion, because that's what a z-score turns into, right? If I do equals norm dot s dot dist 1 comma true, I'm finding what percent of the population, or what is the probability of picking somebody that is to the left of the line that I draw at z equals 1, which is 1 standard deviation, to the right of the mean, above the mean, which means I'm interested in the left side, everything here, that's 50%, which is the part that's less than the mean, and this 34%, which is the half of the 68%, that's where that 84% is coming from. So 84% of the population is less than 1. That's what this norm.s.dis is doing. I need to use the z-score to turn it into a probability or a proportion. From there, I'm answering the question. Well, first I need to determine or think about whether I want the left or right part of the distribution. So you may need to find the complement to your probability / proportion. And we've talked about how to do that. If this is 84%, the complement is 100% minus that, which is the 16%. My goodness, that's a lot of decimals. Let me just kind of have them have matching decimals. And then answer the question with the probability / proportion you need. That's basically the z-score process. Okay. And then in this particular question, we're adding in the evaluations thing here. I'm not shocked because the distribution wasn't normal. And so this approach does not apply to my distribution. Keeping in mind that it does apply, the z-score process and all of this statistical thinking does apply once we go into the sampling distribution, because in the sampling distribution, according to the central limit theorem, we end up with a normal distribution of samples. And so we can apply z-scores and to confidence intervals and things like that. All right. Hope that helped a little bit.